it away now?
Yeah, they're all on and they are ready. Go for it. You guys ready? Thumbs up if you want to hear from Dr. Figer.
All right, I see thumbs. Thank you. Thank you, Jessica. Thank you all for being here. It's a pleasure for me to be able to do this. I really enjoy giving talks like this, and it's very timely. It's an exciting time for me because the topic has been in the news. I don't know if any of you have seen that, but I'll say a little bit about that later. And Jessica, I don't know if you're making a recording, if you decided to do that. Okay. So I'm going to share my screen. And if you could, please give me a little thumbs up if you can see my screen. Okay, good. So I'm going to be talking about black holes. And maybe you've heard of them before. Maybe you've seen them in Hollywood movies like Interstellar, or when I was a kid, there was a movie called The Black Hole, which was exciting. And before I start, I just wanted to say a little bit about myself. I'm a professor at Rochester Institute of Technology, and I'm director of something called the Center for Detectors. We make the detectors that are inside your camera. And they're also the kinds of detectors that are on the Hubble Space Telescope and are on other telescopes. So we make the device that records the images and gets the data. Another thing is that I grew up in a place that you might have heard of. It's a little town called Wickliffe in Ohio. And now I live in New York, but I grew up in Wickliffe. So I know where Mentor is, and I think that's where you are right now. And I just visited there a few weeks ago. So I'm from where you are right now. So I'll go ahead and move on. And what I want to tell you about today is I want to tell you what black holes are and how they're made, where they are, where you can find them, but I don't suggest you go very near them, and I'll explain why in a little bit. And then how do we find black holes? Seems like it might be difficult to find something that's black in the dark of the sky, right? In space. That seems very weird. So we'll try to figure out how we find black holes. So first, what are black holes? Well, before I tell you what a black hole is, I want to tell you what a star is. Now, that image on your right is a picture of the sun. And I'm showing you the sun because the sun is a star. And the sun is made of the same thing that stars are made of because it's a star. It's made of gas. It's mostly hydrogen gas. And the hydrogen gas in the center of the sun is under enormous pressure, millions of times higher pressure, and millions of degrees Fahrenheit higher temperature than what we're used to here on Earth. And because of the high pressure and the high temperature, the gas particles are moving around real fast and they smash into each other. When the gas particles smash into each other, they become helium. So the hydrogen becomes helium. But something else happens. That collision is an explosion, and it produces energy in the form of light that flows outward from the center to the edge of the sun, and then it leaves the sun. So we can see the sun because of the light that's produced in the core of the sun, where all the explosions are taking place. So the sun is sitting there. It's not contracting. It's not expanding. It's static in equilibrium. Gravity is pulling it inward, but gas pressure is pushing it outward, and it's in perfect balance. What would happen if the gas pressure disappeared? If the gas pressure disappeared, gravity would take over, and it would collapse. It would fall in on itself. So stars burn fuel, and at the ends of their lives, they run out of fuel. And without any fuel, they collapse. And that's the start of what would become a black hole. Now, it turns out that only the most massive stars form black holes because, for instance, with the sun, when it loses its energy and it collapses, it's actually going to stop collapsing when it's about the size of the Earth. So the whole mass of the sun which is hundreds of thousands of times more massive than the Earth. All that mass in the sun is going to collapse into something the size of the Earth, and it's going to be called a white dwarf. Really massive stars collapse into a black hole. And I'm going to look at my chat here just so I can stay current with what you guys are saying. And feel free to tap in any questions, or if you want to shout at me about something, just say whatever you want. You can tell me if you know answers to any questions or if you have any thoughts about what I'm talking about. So I'm going to move on. This is a picture of the sun at the end of its life. It's going to lose all of its energy. It's going to collapse. It will form a white dwarf, but more massive stars form black holes, okay? And here's an illustration of a star dying. It's at the end of its life. It becomes a supernova. It explodes because all the matter crashes into the very center. So at the very end of this sequence, you see an explosion and the materials crashed into the center. In this case, there's a bright dot in the middle because this thing is going to become a white dwarf. But a more massive star, the end result for a more massive star would be that thing in the center would just be black.
Black holes can be very massive.
Okay, so I told you a little bit about
I don't know how to get back on there.
how black holes are made, and I want to give you more information about why it's called black, because I really didn't describe that. Take a look at this picture on the right. It looks like a simple picture. There's a red dot in the middle, and then there's this black circle. And what this is supposed to show you is that within a certain distance of the center of a black hole, the red is the center of the black hole, within a certain distance, nothing can escape. And that distance is at the Schwarzschild radius, and that thing is called the event horizon. So basically, when you take matter and crunch it into a small spot, the gravity now is so strong near that spot that nothing can escape, not even light. Because light can't escape, this disk appears to be black. So if there's any amount of light, I hope you can see my cursor. If you can see my cursor, maybe someone can type something in the chat. If you look here where my cursor is, just inside the event horizon, see where I'm putting it? If there's any light here, right there, it's going to get sucked into the red thing. It can never leave. If you were in a spaceship and you flew next to this event horizon, be careful, don't cross it. If you cross it, you'll never come back. You'll be gone forever. So this black hole is called black because light can't escape. Light can't escape because the gravity is so intense. The gravity is so intense because all this matter has been crushed into a single point.
Okay, I don't know what you did, Bubba.
Okay?
Single point.
So astronaut Tristan is asking why. And I'm not sure if the question is, why can't light escape, or why can't an astronaut escape in a spaceship?
Well, why can't astronauts escape?
Oh, because if you can see my cursor here, it's outside the event horizon.
What is that?
So the event horizon right here is the place from which nothing can escape due to the gravity and the red dot. So
They're very massive.
If you go past this event horizon,
Oh,
can't get out. The gravity's too strong.
shoot.
So let's go on. So I tried to explain black hole here, and I have a simple picture here,
Yeah.
and hopefully that makes sense. Here's a really pretty picture, right?
What is the acceleration disk?
So
The accretion disk.
yeah, accretion disk, and there you can see it. It's probably the prettiest part of this picture.
Oh,
So if you look here, you can see this surface, this event horizon surface, which looks black, right? If you go inside that black thing, you can't come back out,
oh.
okay? But look at the gas outside of the event horizon. It's swirling around.
Oh.
And I don't know if you ever when you flush a toilet, and the water goes.
Yeah, like a smell. When I flush the toilet, I think about that, and I was like, oh, that could make you think of a black hole.
Yeah, yeah. I think of maybe the word spiral. It seems like the material
Spiral.
spiraling. So you could think of this black hole as the big toilet in the sky, and
Oh,
the material is flying around in circles and getting closer and closer and closer to the event horizon. Eventually, it passes the event horizon, and it can't come back. Okay? You notice, by the way, this is just a painting because no one's ever been able to take a picture like this. I'm going to show you a picture of a real black hole later, okay?
real?
Yeah, I'll show you. Now, as I said before, only the most massive stars can form black holes. Here's a picture of one of my favorites because I discovered this. I discovered this, and this is the picture I took with the Hubble Space Telescope. It's called the Pistol Star. If you wanted to know more about this star, you could Google Pistol Star. Look, there's my name at the bottom. And I was at a place called UCLA, or UCLA. It's University of California, Los Angeles.
NASA stands for National Aeronautics and Space Administration.
That is correct. You are correct. And I worked with NASA, and I worked for NASA for a while, and I took this picture, and this Pistol Star thing, this purple thing in the middle, that's a very massive star. It's about 150 times the mass of the sun. It's one of the biggest, most massive stars that we know. And if you look around it, there's this red stuff stretched
What is
around
that?
it. So that used to be part of the star.
Part of the star.
It exploded, and all this material
Whoa.
came flying off. So it's not dead yet, but it's going to be
Not
dead
dead?
soon.
Soon?
Yeah, and I'll be very sad, and it's going to make a black hole. Well,
Oh,
when I say
shoot.
soon, I mean within a few million years.
Few million years?
Yeah.
Oh,
but
that's a long time.
it's a long time. I don't think we're going to be here to see it, but you know, it's not a long time when you think that the universe is 13 billion years old. So
13 billion?
yeah.
Wow, that's old.
Well, that's 13 and 9 zeros. So that's a long
13
time.
9 zeros.
Yeah. So
Wow.
here's now I want to talk about an actual black hole, a real black hole, okay? Because I said I would show you one. And this picture on the right is a picture, it's a cartoon. It's a painting of the galaxy, our galaxy. We live in a galaxy. The sun is one star.
The Milky